Okay, now share the one note. Okay. Okay, someone joining actually due to this. Okay, so today, mm, so date is 2000. Okay, so I think this is the last unit, last topic of mm, mm, of unit number one. Okay, curve tracing. What we understand means curve. That means we understand that what we draw the line is anyway that is a curve. But mathematically, we can represent it is represented by some equation or expressions. Okay, it's a function of two variables x and y, and in Cartesian coordinates, and in the curve may be represented by in parametric form in the polar coordinates and some other form also. Okay, so mostly we do the problems in this Cartesian and polar. Parametric is I think not mentioned. Okay, let me see ahead as according to course coordinator of first semester. Uh, so curve tracing is what means what we understand means how just Okay. Alright. Hmm. So it is sketching. Sketching, that means drawing. You can say sketching of the curve by how we sketching. Okay. So by the different characteristics of the curve. Okay, we are not directly drawing the curve, but we extract them some characteristics, and on the basis of characteristics we move the curve so that it's become actual. Okay, like that. So it is sketching of the curve by understanding different characteristics with Cartesian in Cartesian curve. Okay, so these things is a function of xy or in capital XY. You can see. Second one, parametric. Parametric curve. So here we write x of there is the one y is also function of this t. And last one in the polar curve. Those are theta. So now the we study about the steps or methods to draw the curve. So working rule I'm going to write. So for the given expression or curves, what we extract the things. Okay, tracing of Cartesian. So next point is coming to the tracing of Cartesian curves. So the procedures are as follows. Procedures like writing here one. First is coming symmetric. Okay. So this symmetric is any curve definitely it is symmetrical about x-axis, y-axis, symmetrical about the what the means origin. So like symmetric in opposite quadrants, symmetric about the line. These are the some characteristics we find. So that now we can further we again the next characteristic we find like that where could be the tangent, how we intersect in with the x-axis, is origin is passes through or not, intersection with the coordinate axis, some spatial points, like that we some extract the things. Okay, region. Region also. If this curve is in this region, will be available or not. Okay. So such type of characteristics we see. So in symmetry, so first symmetric case, we want to write some song. Symmetricity, we know if the power of x is the even, so this is symmetrical about the y-axis. If the power of means y is even contains the equation symmetrical about the x-axis. Okay, so writing symmetry about x-axis. So in this case, what? So how we observe symmetrical about x-axis? If the equation of a curve remains unaltered or unchanged when y is changed to minus y. Okay, so that is interesting. So symmetry about x-axis if the equation of curve remains unaltered when y is changed to minus 5. Okay, that is if only even powers of y occurs in the equation. Second one, similarly symmetrical about this is symmetrical x-axis. Okay, hello. अच्छा एक हम्म, आ, हाँ yes yes 4807. Hmm. Symmetrical about y-axis in similar manner. So what the equation of a curve remains unchanged when x is changed to minus x, that is only even powers of x occurs. Okay, that means occurs in the given equation. I'm not writing here for okay unnecessarily. Third number. Now we see that this is symmetric about x and axis we know already. Symmetric in opposite quadrant means about the origin you can say symmetric in opposite quadrants. Okay, while you writing the when you're drawing the curve, this statement is very necessary. Okay, for the given expression. If you're not writing directly draw the curve, so you will get only 10% marks. So the the marks is based on this whole statement. Symmetric in opposite quadrants. So how we check this one? If if the equation of the curve remains unchanged when both x and y are changed to minus x and minus y respectively. Respectively. The curve is said to be means not if the equation of curve remains unchanged when both x and y change to respectively, the curve is said to be symmetric or symmetrical in opposite quadrant or opposite okay, we have to write same manner in a symmetrical opposite direction. So opposite quadrants. Okay, so mostly you know these all the things, something, but some of the student would forget or some confusion. That's why I'm writing all the things. We directly come to the problem, but we need to give these statements. Symmetric about the line y is equal to x. Symmetric about the line y is equal to x. Okay, so how we do this? If the equation of the curve is unchanged, same thing when x and y are interchanged. Okay, so when we understand symmetrical about y is equal to x or x is equal to y, when you interchange the xy, okay, means x is changed to y and y to x, like interchange that means. Next, it's symmetrical about the y is equal to minus x. Okay, so in this case, okay, I'm not writing the other things. I'm writing directly if the equation of the curve remains unchanged, y is equal to minus x, unchanged when x and y are changed to interchange is like that, but in negative. So better to write x and y are changed to minus y and minus x so that it's clear. Hello. Hi, yes, morning. Yes, already I talked to your means guide actually. I will available after 12:15. Okay, because now I'm taking class. Okay. So change to minus one. This six. This is the case for. when it is symmetrical about y is equal to minus x. Now we come to the second one. Okay, first we have seen the symmetric of the curve. Second one, origin. So what type of origin? What is the behavior of the origin? Okay, so that we are coming to the origin of the given curve. So what we do means here we check the given curve is passes through origin or not. It's very easy to when we take x and y both are zero. So that means if these equations are coming zero, that means passes. That means the expression does not contains any constant terms. If the expression of function of x y contains any constant terms, means free from the variables, okay, so it is not passes through the the origin. Okay, so I can directly write mm, the curve is passed through the origin, through the origin if the equation of the curve is free from the constant. Okay, okay. Suppose further means what will happen means if the origin is very important point. The next origin, what we think. Is it any tangent at the origin? These things we study about at the origin. So these things, now you see like that. This is the one. Next, two. So tangent at the origin. This is the passes through the origin. So now this is okay, we can write third point like tangents at the origin. It is not strictly you follow. I mean, first you write symmetric, then origin, then tangents at the origin. So it is you can any way you write, no issue. First you write origin passes through or not like that. Tangents, then you can find. So it is not necessary. You can move in that manner. Means if the curve passes through origin, then tangents, then its tangents at the origin at the origin means evaluated or calculated by at, tangents at the origin are found are found by equating equating the lowest degree terms lowest degree terms of the equation to the curve to the curve. Lowest degree term of the equation to the curve, not to the to 0. Okay, this is 0. Means to say tangent at the origin, how we find? First we check it passes through origin or not. So what we do, the lowest degree term of the expressions, you equate to the 0, you'll get the tangent to the curves. But there is the other case. There may be not only one tangent, maybe more than one tangent. That means, have you things have you heard that the single point and multiple points? Okay, means ordinary point or a multiple points. So ordinary point means what? Means the curve is passes through there is the one means branches, multiple points. That is the more than means the point at the curve has only one branches, that is called the ordinary point. The point of the curve where the branches more than one from the multiple points. Okay, so in multiple points we have there is the double points. That is the very important. It represents some characteristics. So there is double points. It has the two tangents. That means two branches. Means in terms of tangents we are telling when the double point is called the cusp. Okay, the node and the isolated point, or you can say some conjugate point. Okay, so node that means what? If we find at that point the two tangent which are distinct, that is called the node. The point is called the node. If that point there's a two tangent but coincide, that is the point is called the cusp. Okay, and conjugate means the imaginary tangents at that points. Okay, that is called the isolated, or you can say the conjugate points. Okay, so these all the points is on we found on the curve. Okay, this is some special characters or special behavior of the curve at this point. Hmm. So third is next we coming to the fourth one. What we write? Mm, origin is not only for the origin. We say mm, singular multiple points of a curve. It is singular. So, so singular and multiple points means here we define nature of the origin. Okay, so it determine determine the nature of the origin as to whether origin is an ordinary point or multiple point. Multiple point. So that means if the origin is found to be double double point means means origin is what, ordinary or multiple points. So on that double points, this is the important double point is coming under the multiple points. So double points are space or something, uh, to be double point determine whether it is a node, a cusp, or a conjugate. Okay, so these all example we discussed because different equations are there. In that case, we can discuss the node and cusp on the things, because otherwise too much to be in the problem we will discuss. Other we are coming to the next is the fifth one. Fifth one is intersection with coordinate axis. Intersection with coordinates. Coordinate axis. Find the points, means in this case what we do, we find the point whether the curve cut the axis of coordinates. Okay, so in this case you know how to find, because when you take x is equal to 0, so it's give the, it's where intersect to the y-axis, when y is equal to 0, where it is intersect to the axis. So I'm just writing, we know these things. And one more things with this, finding the intersection point, also find the tangents at this point, because is it's move or it's moving tangent, that means now it's now it's moving, touching, after that they move their directions. So in this case, um, what we do, find the points where the curve cuts axis of coordinates. Find also the tangents at these points if necessary. Besides, also find out points whose coordinates clearly appear to satisfy the equation of the curve. So find out tangents at this point. Find out the points whose coordinates clearly appear to satisfy the equation of the curves. And also find the tangent at this point if necessary. Means whether it intersect the x and y axis. This is also important, and also find the tangent at this point. Okay, one more things in this things. If the curve symmetrical about the line y is equal to x, then find out the points of intersection of the curve with this line and the equation of tangent thereat. Okay. If it is passes through a intersecting through, so we need to find the tangent at that, uh, the y is equal to x is also. Okay, as we need the things, we do one. Okay, now we at least write so that we follow. We check while drawing the curve, sketching the curve. if the curve is symmetrical about the line y is equal to x, then find out the point of intersection of the curve with this line, and the equation of this. So this is all about the intersection with the coordinates and the line. Now the next is the asymptotes. So we already study how to find the asymptotes. So find all the asymptotes of the curve. It means what? The curve will not go beyond its asymptotes. Means it's not crossing the curve. That means it always inside. It's not go beyond them. It's because not crossing the these things. Now next is the region of the curve. Say one number region. So region means here we calculate. So the curve is exist or not in this region. Means like x greater than 2 and less than infinity. Okay. So this equation is not satisfying. Okay, so that's why not existing. So at least we are getting the information. The curve will not here, and how they move through the origin and intersecting like other things. You can draw the curve reason. So this curve is you writing without giving the values of x and y. Okay, you can say why we are studying this thing because when we give x and we get the y values, we can easily draw the curve without finding these all the things. Now this is okay, but by this properties, using such type of this characteristics, we can draw the curve also. Okay, a region first, if possible, solve the equation for y or x, and after that, what you see behavior of y or x on different values of the other variable, giving particular attention to these values for which y or x becomes infinity or zero or imaginary. Generally, x is equal to 0, y equal to 0 is convenient. Is when we are equating solve equation for x y, so for some values of x and y to become infinity or 0 or something, so by which we can trace the curve. Okay. then the behavior of y or x different values of the equation. So for different values of of the other giving particular attention to those values for which y or x becomes infinity or zero or imaginary. So that means x is equal to 0, y equal to 0 convenient. And one more thing we can observe that the variation of y as x decreases from 0 to minus infinity. There is a symmetric either about y axis or an opposite quadrant, only values the axis need to consider. Okay, these are the things we see. And hmm. And also we find out the point of inflection if it exists. Okay, point where the curve changing its direction. And the last point I'm writing, that is the special points 7 or 8. Special point, that means if we find the derivatives is equal to 0 or infinity, the points where the tangents is parallel or perpendicular to the x-axis, means to say, so there may be point exist. So here we writing number one more point is there. So find the points of the curve where dy by dx is equal to 0 or infinity, that is the points where the tangents is parallel or perpendicular to the x-axis at such points coordinates or abscissa. Okay, I'm a little bit hurry having vibe generally from increasing to decreasing or vice versa. So one other points. Other points find some special points on the curve if necessary. Okay, some more points if possible we can find. So these all the things you read properly and we discuss how to trace the curve for the given equation of a curve. Okay, so by writing these statements and we slowly draw the curve. Okay, so today we have crossed our time limit and okay, in the next lecture we draw the curve use by the following procedures what I've written. Okay, so now I'm sharing this notes. Last lecture maybe today. So okay, just I'm dropping the words. Okay, other things we discuss in the next lecture. Okay, okay. Now I'm leaving the class.